We're going to pick up right where that last video left off with problem F, testing for odd versus even versus neither. So we're going to run with our test. So I'm going to change the sign of these z's. So I'm going to do q of negative z. So the opposite sign of the z, because that's the test always for symmetry. And I'm going to change all of the signs of the z's in the problem. So it's negative z to the third. And then this will be plus negative z, okay? That's the top. The bottom then, negative z to the third, and then 4 times negative z. Okay, so now we need to kind of check each one of these terms individually. So if I look at the first term, this 3 and this negative z to the fifth, well, anytime I have an odd power, this piece is going to keep its sign. So this is going to be negative z to the fifth. So that makes this whole first term negative 3z to the fifth. So it's in fact the opposite of what it was originally. Okay, so look at the second term. Again, anytime you have an odd power, it keeps its sign. So this is now going to be positive 6z to the third. Okay, and then this one's going to be negative z. So far, every single thing has changed signs. Okay, let's look at the bottom. This one's going to change signs as well. Odd power, so negative 3z cubed. And this one is going to change signs as well, minus 4z. Okay, so now look, every single thing has changed signs. So when we were dealing with things that weren't rational, when every single thing, like on problem D, when every single thing changed signs, we said that the problem was odd, right? But when we're dealing with a fraction, if everything on the top changed signs, then that means we have the opposite of the original top. Okay, let me say that one more time. So if everything on the top changed signs, we have the opposite of the original top. If I were to distribute that negative in, I would have this, okay? And look what happens in the denominator. I have the opposite of everything on the bottom. So I have the opposite of the original bottom. Well, if I have the opposite on the top and the opposite on the bottom, a negative on the top and a negative on the bottom will cancel. So that means I have the original top and the original bottom left, which means that my equation is exactly the same as it was before I plugged in negative z, which makes this equation even. Okay, so make sure you're looking for that. It's slightly different when you're dealing with odd versus even, when you're dealing with a polynomial expression and when you're dealing with rational. Okay, so make sure you're taking that into consideration. Okay, let's look at G. All right, same thing. We're checking for odd and even, so I'm going to change the sign. So change the sign of all the x's. Okay, and on the bottom, I'm going to change the sign again. Okay. So let's look what's going to happen. This one is odd, so it keeps its sign, but it's multiplied by a negative, so that's going to cancel out and give me 2x to the fifth. So it changed from the original. This one, it's an odd power, so it keeps its sign, which changed from the original. But this one, the plus 6 stayed the same. So they didn't all change, so I don't have like I had in the last problem where I can take that negative out. It's just not the same expression. On the bottom, I have 3x squared because the negative x is raised to an even power, so it changes signs, and then plus 4. So the bottom is exactly the same as it was, so that would lead me to believe that it's even, but the top, everything changed except for one piece, which means that not everything changed, which means that this is neither. Not odd or even, because we can't pull that negative one out like we did in the last example. All right, let's look at H. Changing the signs again. And this is a cube root. Okay, so let's think about what's going to happen with that. Okay, so this is negative 3 cube root. 8 times negative x is going to be negative 8x. Okay, and when you cube root something, when you cube root it, just like when you raise it to the third power or raise it to an odd power, right? This interior piece keeps its sign. So when I cube root this, okay, the answer to the cube root of this is going to be a negative. All right, so when I do that, here's really what I'm doing. I can cube root the 8. The cube root of negative 8 is negative 2. I cannot cube root the x, so I'm going to leave that inside. So this is now, what, 6 cube roots of x? Whereas this one, this cube root of 8 is 2 as well. So this is really negative 6 cube roots of x. So I have the positive version, and I have the negative version, so they have opposite signs. So since they have opposite signs, this is odd. Okay? Let's take a look at this guy. I'm going to change the signs. So I'm going to change the sign of this top. And this one is rational, so we need to look at what the top and the bottom do in comparison to each other, right? These are the ones you have to be careful on. All right, so looking at the top, if I have the 2/3 power, remember this is the power over root. So when I take the third root, this is going to keep its sign, so this is going to be negative. But then if I square it, it's going to become positive. So the negative d to the 2/3 power, because one of these numbers is even, is going to end up being the same thing as positive d to the 2/3 power. So I'm left with what I had originally on the top. Okay? The denominator, if I have negative d and I square it, that becomes positive d again. So this is positive d squared. So I have the same thing that I had when I started. So this problem is even. Okay? So what they've done at the bottom is they've come up with some general rules of thumb for you when you're talking about odd versus even. When you're dealing with polynomials, remember polynomials are non-rational, so those are like x squared plus 3x plus 5, things like that. If none of the signs change, the function is even. If all of the signs change, the function is odd. If some change, but some stay the same, so you've got a little bit of mix of even and odd, it is neither. Okay, the polynomials I think are really easy to check with. When we're dealing with the quotients or functions or what we'll call rationals, right, so fractions, okay, if you have an even and an even, so the signs didn't change and the signs didn't change, then the signs didn't change, okay? If you have a no sign change and a sign change, or vice versa, the top and the bottom, then the sign changed and it is odd. If the sign changed on the top and the sign changed on the bottom, those two sign changes cancel out, so it will be even. And then if you just have random stuff happening, it will be neither, okay? So hopefully that'll kind of tell you what's going on. But you are going to have to know how to perform the odd versus even test and know what kind of symmetry that it means you have.